In this video, we're going to talk about probability. Now, before we dive into it, we usually have an idea of what probability is, but I'm going to kind of loosely define probability. So, loosely, probability is the chance that an event will occur or the chance that something will occur. That's supposed to be a U. Just went right to the R. There we go. Probability is a chance that something will occur. Okay, so we have a couple ways to think about probability. Let's start with some kind of more theoretical probability. So let's classify, looking at number one, each event as having a low probability, a high probability, or a 50-50 chance. So in this book, they kind of focus on probability as being like based on data. All right, based on evidence. So we're going to kind of use that to help us think about each of these. So let's classify an event as low, high, or 50-50. Okay, and 50-50 means like you could flip a coin, it could go either way. All right, that means 50% chance either way. So let's describe the evidence we have for that. So getting to school on time. Now, this has to be personal for you. For me personally, to get to school on time, it has a high probability. And the reason is this is my job. When I go to school, it's my job. But I tend to run on time for my job. I always try to be on time. And that the reason is, if I'm not, I got a bunch of students who are waiting on me. And then I could potentially have a bunch of complaints for the fact that I would late, especially if I'm late a lot. That's unfair to the people who are busting their butts, getting there on time, and me not being there on time. It's problematic. So not only is it my job and I should be on time to my job, but people are depending on me to be on time to my job. So that's kind of the idea. It's a high probability I'm going to be at school on time, just because it's my job, and I always try to be on time, and I am usually on time. So the evidence is overwhelmingly I am on time for my job. All right. But it might be different for you. Maybe you're somebody who runs late. I have a friend like that where they run late, and it's more of a low probability that they're going to be there on time. Okay. Sure. Answer for yourself, or maybe it's 50-50. Maybe you've got a bunch of people depending on you, and it just really depends on how the wind goes that morning. All right. But answer it for yourself. What about getting into a car accident? Okay, so this one for me, again, is a low probability. And honestly, it probably is for you too. Now, maybe it's a low probability for you because maybe you don't drive. Maybe you take a bike and you're like, well, I'm not in a car, so I'm not going to get into a car accident. All right, sure, fine. Maybe you walk. Maybe you live very close and you can walk to the school. But the truth is that the chance of getting in an accident is very low. And the reason I know this is insurance companies. There's a reason insurance companies exist. They exist because they're going to make money. And they're going to make money because the majority of people do not get into car accidents that require them to pay out. So they make billions and billions of dollars, pretending that we all might have the potential to get into accidents. They're going to cost a lot of money. And the truth is, we very rarely get into accidents. With all the times I'm on the road, I very rarely have been in a car accident. So with all the driving I do, the evidence is I've rarely been in a car accident. Rarely happens compared to the amount of driving I do. All right. And that's probably the same for you too. You might have a reason why it isn't, but you could kind of state that for yourself. Okay, so when the weather forecast calls for 60% chance of rain, what do you think this means? And explain. Okay, now there are a couple ways to think about this. One way to think about it is that 60% is a greater than 50% chance. So it has a quote unquote higher probability of happening. All right. So it qualifies as a higher probability of happening. So it's a higher probability since it is greater than 50%. 50% is like the middle, right? But there really are a couple scenarios you can use to kind of think about this. From a weather standpoint, when they say there's a 60% chance of rain, what they really mean is that in the area that they're talking about, 60% of it will probably see rain that day. 60% of the area will see rain. So 60% of the area will see rain. And then there's another scenario that could be thought of. It's to be thought of as 60 out of 100. And when you think of that, 60 out of 100, that's like Groundhog Day scenario. Okay, let's say, or one of those like repeating a day scenarios, right? It's the idea that if you could start the day over and over again 100 times in a row, 60 of them would have rain that day. All right, that's the idea. Now, I like that it really is talking about the area, but it is also the idea that it's a higher probability or chance of happening. So if I'm trying to decide if I want to wear my comfy shoes, which aren't waterproof, and some waterproof shoes, I'll probably put on the waterproof shoes because there's a higher chance it's going to rain. All right. So they define probability as the ratio of the number of times an event occurs to the total number of trials. So it's a fraction. That's what ratio means, right? We're talking about a fraction. The number of times something happens to the number of possible outcome or possible trials. So trials is kind of a funny word, and it does kind of depend on the scenario we're talking about. Let's look at an example of what you can use for the context of trials. So let's say you bring 15 paintings to sell to an art fair and sell 2 of them. Then the idea is selling a painting would be our event. And the trials are how many paintings you brought, which are 15. So the probability of selling a painting at the fair is 2 in 15. So the actual number of paintings that you brought, the opportunities to sell something, those 15 opportunities, of those 15, only 2 of them sold. All right. So let's kind of use that to do an example. So let's say we have a 25 question test, get 21 questions correct. You could say the probability of answering a question correctly is 21 out of 25. What are the events? What are the trials? Okay, so the event is answering the question correctly. Answering the question correctly. All right. The trial in this case is the number of questions on the exam. All right, on the exam itself. So those are the 25 opportunities you have to actually answer correctly. Okay, what are the events and trials in problems 1A and 1B? All right, so going back to our little theoretical examples earlier, in getting to school on time, the event would be being on time. But the trials in this case would be the number of times you actually go to the school. And I'm assuming they're talking about getting to class, so total number of class meetings. Here, I'm going to kind of zoom in here because I'm writing really small. Total number of class meetings. There we go. Squeezed it in. Okay, part B, getting into a car accident. So in this case, the event is a car accident. Here, I'll just put accident because of space. And the trial is driving in the car. All the times you drive in the car. All right, so there's how we define event versus trial. The event is usually what we're after. It's what we're talking about. Trial is how many opportunities the event had to occur. All right. Okay. If you're choosing a student at our college at random, estimate the probability they would be a working learner. A working learner is somebody that works full time and attends school full time. I'm going to estimate that's probably a relatively low probability. We do see a lot of full-time students, but they often aren't full-time students. Full-time is 12 credits, I believe. Okay. So we're talking about 12 credits typically. And full-time by definition is typically 40 hours a week, though it could be somebody's salary, which means they might possibly work more or less, which would be lucky. But that's the idea. So it's going to be a low probability. We're going to be talking about a small percent. I don't think it's like really small, like a 1% chance, meaning every 1 out of 100 students, but I'm going to go ahead and I'm going to make it pretty low. Let's set it at like 10%. Let's say 10% or so fall into that category. And I'd be interested to know if it is in fact that low. So how would we find that information? How would the book find out that information? That's data they'd have to collect. And we would have to collect the data. We would have to actually survey students. We'd possibly go out and ask a bunch of students and see how many we ended up with. Maybe we at least ask 100 students and see how many out of that 100 end up saying, yeah, I work full time and I have a full credit load. All right. So we'd really probably want to survey students. It's possible the college has that information. They certainly know how many classes the student's taking. But there's possibilities that they've done surveys through like student services where they kind of get an idea of work schedules and how much people are working. So, but it's still a survey. They'd still need to ask that question, and that's how you would get that information. So on that theme, they kind of envisioned that being in a class, maybe we could take a poll of how many students in the class are English majors, math majors, like broccoli, have siblings, have a twin, work part-time or full-time, or own a smartphone. Okay, so I kind of sat down and thought, all right, I'm gonna give you guys some numbers for this. So let's say this is out of a class of 15 students, a pretty nice sized class. And of those students, let's say 2 of them are English majors, 1 is a math major. Let's say 8 like broccoli. Let's say 12 have siblings. Let's say 0 have a twin. Let's say 13 work. Sorry for the pause. Okay. Sorry, let me get rid of that obnoxious little thing. It's going to get mad at me. There we go. All right. Owns a smartphone. I'm going to guess most likely everybody, but it's possible there are some students who don't. They might, just own a basic phone, not necessarily a smartphone. But I'm going to do this off of my own experience from students. I'm going to say in this particular class that I'm, making up, all 15 have a smartphone. Okay. So they want us to write this as a decimal, fraction, and a percent. So get your calculators ready. As a fraction, that's the easy one. It would be the number of students out of 15. So 1 out of 15, 2 out of 15, 8 out of 15, 12 out of 15. Now, 12 out of 15 is actually reducible. We could divide top and bottom by 3, and we should reduce it then. So that would be 4 out of 5. Student has a twin, 0 out of 15, which is just 0. So I'm going to put 0. 13 out of 15, and then 15 out of 15, that would simplify to 1. Okay. So for 2 out of 15 as a decimal, grab your calculator and do the division. 2 divided by 15. And I come up with 0.13. Here, I'll put the 0 in front. 0.13. And I'm rounding to 2 decimal places. All right, let's do 1 out of 15. I'm getting 0.0. And then since I'm going to have to round that, it would actually round to 7. That 6 would round to 7 since it's 6 repeating. All right, so 0.07. 8 out of 15. That's going to be 0.53. 4 out of 5 is actually going to come out to 0.8. 0 is just going to stay 0 as a decimal. 13 out of 15, that comes out to 0.87 if we're rounding. And then the 1 is just going to stay a 1. All right, so there's the decimals. Now for percent, we're going to move the decimal over twice on each of them. So this will be 13%, 7%, 53%, 80% when we move that, 0%, 87%, and this would be 100%. All right, there we go. So we use the word frequency to describe how often something happens. What is the relationship between the frequency of an event and the probability of an event? So the frequency becomes the number of ways that event occurs. Okay. So when we say that we're finding the probability of an event, that means that it's the frequency of that event over the total number of trials. All right. The probability of any event can be represented as a decimal between the lowest possible number is 0 and the highest possible number is 1. 0 means it has no chance of occurring. Now, it could also mean, especially in the way we've been working with probability, that we've just not seen it occur in the data. And for that reason, it's possible that things that were thought to have a 0 chance of happening actually just have a very low chance of happening. 1 would mean that it's 100% going to happen. It is going to happen. So 100% chance. All right. And that means that we just keep seeing it occur every time we survey. So we keep seeing it occur every time. And it's possible that we just haven't had the event where it doesn't occur. So it possibly could stop happening, but based on data, it seems to keep happening. Can an event have a probability less than 0? No, that's impossible. Okay. It's got to be 0. 0 means not, it doesn't happen. So it can't have anything less than that. And there you go. That's probability.